Good morning to lecturers. Today I'm going to present my final year project, solar powered autofish feeder for freshwater aquaculture cage.
So today we will start with the recaps on my titles, background research and A1 infographic. This is my A1 infographic. My title is Solar Powered Autofish Feeder for the Freshwater Aquaculture Cage. For the background study, the freshwater aquaculture is one of the important economic sectors in Malaysia. In order to constantly supply seafood, freshwater cage culture is one of the solutions as it fulfills the demand as well. Currently, this industry faces three problems. The first is feeding. Most of the fish farms use labor to feed the fish, and it causes overfeeding because of the misconcept, giving more as it grows faster. That leads to the second problem, pollutions. The undigested food causes the water become toxic as it harms the environment and the fish health. Then the last thing is manpower. The big farm that require manpower to run it and it is very costly. The objective is to research on the design of the autofish feeder. The second is to evaluate the design of the autofish feeder. The third one is to propose an alternative design of autofish feeder for cooking area. For the research method, this research used the qualitative method, which is interview, observation, and video observation. So I interviewed 3 interviewers, and this is the result. For the first one is Mr. Chua Hua Beng. He is the founder of the Pure Japan Aquaculture. He said the design itself has to be low cost because his farm is quite big. And the second one is Mr. Hill. He is a farm manager for the PM Aquaculture. He said an autofish feeder should have the circular feeding function for the fish fry and the shelf improvement, and it should be less maintenance. And lastly, Mr. Lai is the founder for the Himing Farm. He said the autofish feeder can be powered by the alternative energy such as solar energy. Next is a technical drawing. As you can see, it has 4 different viewports: top, front, perspective, and right. All of the viewports separated by the dimensions in the mm. And the next one is the product design specification. For this model, I named it is MX001-2, and the brand itself is Maximus because I want this product can maximize itself to the user. And the dimension, if the stand is 256 times 133 width and times 420 height. With the clamp gauges the difference of height by 1 mm, 490 mm. For the hopper is this hopper can fit of 6.5 kilograms of fish feed, and the materials of these hoppers are aluminium because it's easy to shape. The stainless steel for the inner frame because it has a stronger property. Screw, Arduino, solar panel, keypad, LCD monitor, servo motor, and the lithium is a battery. For the battery life is 10,000 mAh, and it can last for a week. So it has built in with the Wi-Fi function, so you can control it remotely, and it has 3 colors variation: black, yellow, or black and white, or white and gray. Comes to the last part of the infographic, that is the sketches and idea development. This is the first sketches that I proposed, and it was rejected because it doesn't look attractive and it is rigid. the second sketches. The researchers done the research on the drag of coefficient on shapes. The lower the drag coefficient, stable the product in the windy environment. So it results the hexagon shapes has the lower drag coefficient rather than the square or the cube. So that's why I trying to design the hopper as a hexagon shape. And the third sketches is I trying to exploring what kind of features that can be added in an autofish feeder. Comes to the idea tree, it's a combination for the sketches 2 and 3. So as you can see, the design has been improved in a more simple form, but it still looks so rigid and it has to be changing to more automation and the practical design. Comes to the idea 4. The idea 4 is a heritage the characteristic of the design idea 3. So it's improved with the edges that with the fillet curve, so it's not hard edges, so it looks more organic rather than cubic. It has a function and a basic ergonomics design as an idea tree, and it looks more simple and modern. So this is the overall view of my design from the top to the bottom. This is an exploded view for a hopper, control panel, body and the leg. Firstly is a hopper. As you can see, the cover can be opened and the middle has a window for food observation, and the hopper is detachable for easy cleaning purposes. Next is the body of the autofish feeder. There are the control panel. As you can see, the control panel have a cover. It can be opened and closed. And under the control panel, it has the acid and the reflective panel surrounding the design. The reflective panel enables the design visible at night, and there are the solar panel opposite the control panel. This design comes with two types of stand. The first type of stand is standing still stand, and it's very easy to assemble as the video demonstrated. And the second type of stand is a clamp. You can clamp on the fiberglass tank, and it is easy to assemble, just sliding through the connector at the bottom, and you can adjust the thickness that you want. There are three variations in this product. There is the black and yellow, black and white and gray. This is the packaging design of the autofish feeder. As you can see, it has two layers with three compartments. On the top is the body and the stand, and the bottom is the hopper, the largest compartment hopper. This is how it works. As you can see, the black cap is the cap that blocked the food away from the acid, and it will be moved 19 degrees when the time set, and this simulation shows how the autofish feeder clamp on the fiberglass tank with the different size of the fiberglass tank. And this image shows how it stands still on the fish pond, and this image shows how it stands still on the cage. So next we will continue to the modeling part. So firstly I will introduce the tools that I use for the modeling. Is a penknife,
ruler, and modeling board, 1 ply and 2 ply, and some woohoo's, and Mr. DIY spray, yellow and black. After consult Dr. Saifu, so here is the changes that I make. Well, firstly is a hopper. For this time, the hopper are enlarged compared to the previous prototype. This hopper approximate of 4.5 liters, and these hoppers are approximate of 6.5 liters. And secondly, I enhanced the stand design. So for the previous is a modeling board is unstable, and this time I use the metal material as a stand. So firstly is a hopper. The cover of the hopper can be opened as a 90 degree, and here is a window for you to observe the condition of the food inside. And lastly, this is a detachable hopper for the easy cleaning purpose. So next is a control panel. As you can see here, has the 16 button on off, program, and Wi-Fi. This one is a backspace, and this one is a enter. This is a screen. So moving down, here is the exit for the food, and as you can see, here is a reflective panel. Moving to the side, for the ergonomics part, as you can see, here is a space for you to put your finger and increase the grip when you hold it. As an opposite from of the control panel, as you can see, here is the solar panels, and here is some printed texture on it. For the second type of the stand, it is very easy to assembly as well. Just sliding the clamp into the connectors at the bottom, just like this, and then you can adjust the thickness that you want, the thickness of the clamp, and to the fiberglass tank. So that's all from me, and this is the end of the video. Thanks for your time for watching it, and for more detail, please refer to the website that I designed. I already put the link at the description over there. So thank you.